Alright, so again, today we're going to talk about parallel and perpendicular lines. Okay, parallel lines are lines that never intersect. Right, so a good example of that would be railroad tracks. Railroad tracks are never going to intersect. So railroad tracks would be parallel lines. Right, parallel lines are lines that never intersect. Lines are parallel if and only if they have the same slope. Alright, so lines that never intersect. Okay, again, a good example of that would be railroad tracks. Railroad tracks will never intersect. They have to have the same slope for the lines to be parallel. So again, y equals mx plus b is our slope-intercept form. That m right there, which is the number in front of the x, does not include the variable, has to be the exact same for my lines to be parallel. Alright, so looking at my two examples here, I've got y equals 2x plus 1, and I've got y equals 2x minus 3. Now you notice that the 2, m, right, which is the number in front of the x, is the same. So they have the same slope. But they have a different y-intercept, right? This y-intercept's at plus 1, this y-intercept's at minus 3, which is absolutely perfect. Alright, so they have the same slope, but they need to have a different y-intercept. So the same slope, but a different y-intercept for lines to be parallel. Okay, well, Coach Sapp, why do they need to have a different y-intercept? Well, if they have the same y-intercept and they have the same slope, guess what? It's the same line. Okay, so I need to have the same slope, but a different y-intercept. Same slope, but a different y-intercept. Alright, very, very straightforward. Perpendicular lines are lines that intersect at a 90-degree angle. Intersect at a right angle. Okay, so parallel lines never intersect. Perpendicular lines intersect at a right angle. Lines are perpendicular if and only if the product of their slopes is -1. Okay, well, Coach Sapp, what does that mean? It means that their slopes must be opposite reciprocals. Okay, so perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. Okay, what does that mean? Right? Opposite means a different sign. So if it's positive, guess what? You're making it negative. If it's negative, you're changing it to positive. Reciprocal means to, anybody? No, opposite's different sign. Reciprocal means to flip the fraction. Okay, so opposite means a different sign. Reciprocal means to flip the fraction. So parallel lines have to have the same slope. Perpendicular lines have to have opposite reciprocal slopes. I don't care about the y-intercept, guys. Okay, so for perpendicular lines, I don't care about the y-intercept. But they must have opposite reciprocal slopes. Again, opposite means they have a different sign. Reciprocal means that the fraction is flipped. So you have two steps to get the slope for a perpendicular line. Alright, again, looking at my two examples here, I've got y equals 2x plus 1. So my slope here is 2, which again, that's 2 over 1. And then here I've got a -1/2. Right? So I flipped the fraction down here and it became 1 over 2, and then I made it a negative. Opposite, different sign, reciprocal, flip the fraction. Okay, opposite, reciprocal. And this is an example of our special cases, right? So I have a vertical line which has an undefined slope. Always get an x equals number. And then I have a y equals -2, which is a horizontal line which has a 0 slope. All right, those are two examples of our special cases. So looking at my perpendicular lines, it says determine the opposite reciprocal for each of the following. So 2/3. All right, so Ryan, help me out. I need the opposite reciprocal, right? So opposite means I need a different sign. Reciprocal means I need to flip the fraction. So number 1's 2/3. I'm going to flip it and make it, yeah, I'm going to flip it and make it 3/2, and then I'm going to change the sign and make it a negative. Perfect. All right, Hayes, you got number 2.
4 is 1/4.
1/4? Riley, you agree? Negative 1/4. Now I agree. All right, so opposite, again, you got 2 steps, guys. You got to change the sign and flip the fraction. Change the sign and flip the fraction. Graham, what about number 3?
I think it's just positive 1.
Positive 1. Because this is a negative 1/1. When you flip the fraction, guess what? It's still 1/1. Who cares? All right, so all you got to do is change the sign. Perfect. Okay, Ryan, what about number 4? 8/5. 8/5? Huh? Negative 8/5. Fantastic. All right, number 5, 6, and 7 says determine if the following are parallel, perpendicular, or neither. So again, all I care about is the slope, guys. All I care about is the slope. Now, if there's the same slope, then I look to see, is it a different y-intercept? So I'm looking at number 5. I've got a slope. Again, slope is m, which is the number in front of the x, of 1/2, and I've got a slope of 1/2. Those are the same. So right now, those are parallel lines. Then you look to your y-intercept. If it has a different y-intercept, then we Gucci. Parallel, number 5. Again, if it has the same y-intercept, it's the exact same line. So it can't be parallel to itself. It is itself. Looking at number 6, I've got a slope of 3, which we would say as 3/1 if we wanted to. And then this is a negative 1/3. So Andrew, I've got a slope of 3 and I've got a slope of negative 1/3. What are those? Sorry? It says determine if the following are parallel, perpendicular, or neither. So parallel, same slope. Perpendicular, opposite reciprocals. Opposite? Okay, opposite means to change the sign. So this one's a positive 3/1. This one's a negative 1/3. Okay, so they are opposite. And what else? What about the fractions? They're the same? So 3/1 is the same as 1/3? Are they flipped? Okay, so it's an opposite and my fraction is flipped. So what is it? Perpendicular. All right, now looking at number 7. What's wrong with number 7?
They don't have to do this.
Sorry?
They don't have just a regular y axis.
Are they in slope-intercept form?
No.
Nah. So guess what we get to do? Put them into slope-intercept form. And everybody said, yay, right? Okay, so now I want to solve for y. So I need to move this 3x. I need to subtract 3x on both sides. That goes away. You've got 2y equals negative 3x plus 5. You've got one more step. You get the y by itself. So divide by your coefficient of 2. That goes away. You get y equals negative 3/2 x plus 5/2. Just leave it as a fraction. I don't care. All right, so Ryan, help me out. What's the first step for this second one to get it in y equals form? Ryan.
In the y-intercept one?
Yeah, slope-intercept.
Okay, subtract the 2x on both sides.
Perfect. So subtract 2x on both sides.
And it becomes negative 3y minus 2x plus 9.
All right.
And then divide the negative 3 on both sides.
Okay.
And you get y equals negative 2 over 3x plus 9 over 3.
Okay, so let's be careful with our negatives, right? So I've got a negative 2 divided by a negative 3. So those becomes a positive 2/3 x. And then you've got a positive 9 divided by a negative 3. That becomes a negative 3. Okay, so now here is my first line. It's in y equals form. Why did I put it in y equals form? Because now I can look at my slope. Right here I can't look at my slope. It's not the number in front of the x because y is not by itself. So my slope is not 3. If you look at now, what did I do? I put it in slope-intercept form. My slope is a negative 3/2. Then I look here, my slope is a positive 2/3. Guess what? Opposite, this is a negative, this is a positive. Reciprocal, 3 over 2, 2 over 3. So these are also perpendicular. So if it's not in slope-intercept form, guess what? You get to do it. Woohoo! Alright, number 8 says determine if the following are parallel, perpendicular, or neither. So I've got a line with a slope of negative 3 and a line that contains the points 2, 4, and 5, 5. Alright, so a line with a slope of 3. Alright, so on the first one, I have m equals negative 3. Alright, now I have another line that contains the points 2, 4, and 5, 5. So Riley, what would I need to do with those 2 points? Okay, but I don't have the line. Find the slope, right? Because again, what do I care about? I care about the slopes being either the same, parallel, or opposite reciprocals, perpendicular. Alright, so help me out. 2, 4, and 5, 5. Which point do you want to be number 1?
5.
You want this one to be number 1?
Yeah.
Okay, so this is 5 is? Alright, and then 5 is? And then this would be point 2, so this would be x2, y2. Alright, so help me out. Let's plug into slope formula.
Oh, wait, I can't remember. Okay.
You want to change it?
Yeah.
Okay.
I don't like the negatives.
Alright, so let's say that this is point number 1 now, so x1, y1, this is point 2, so it's x2, y2. Alright, let's do it.
Okay, so it's going to be 5 minus 4.
So y2, 5, minus y1, 4, over.
5 minus 2.
Alright, so on the top you've got 5 minus 4. 1. On the bottom you got 5 minus 2. Alright, so I've got a positive 1/3 for a slope, and I've got a negative 3 for a slope. Riley, help me out. Parallel, perpendicular, or neither? Why are they perpendicular?
Because it's opposite.
What does that mean?
Opposite reciprocal.
What does that mean?
Like it's like a fraction.
Okay, so the fraction is flipped, reciprocal, but what else? I have to have I got 2 steps, right? 2 steps to change my slope. Reciprocal, step number 2. Reciprocal means to flip the fraction. What else?
And then the sign is opposite.
Yeah, the sign has to be different. Sign has to be different. So it has to have the opposite sign, so one has to be positive, one has to be negative, and the fractions have to be flipped. Reciprocal. Alright, Hayes, help me out. I've got a line that contains the points negative 3, 1, and 4, 3. We're going to plug into the slope formula. Again, that's y2 minus y1 over x2 minus x1. Okay, so y2 is 3 minus y1 over minus negative 3. So it equals 3 minus 1 on top. So again, 2 negatives beside each other, Hayes, I can change. So 4 minus negative 3 becomes a positive. What's 4 plus 3? 7. Alright, so the first line has a slope of 2 over 7. First line has a slope of 2 over 7. Alright, Ryam, you're going to help me out with the second slope. Alright, so y2 12 minus y1 over x2 minus, alright, on the top I've got 12 minus 5. What is that? 7. On the bottom you got 3 minus 1. What is that?
2.
2. Perfect. Alright, so the second line has a slope of 7/2. So Graham, are they parallel, are they perpendicular, or are they neither?
They're
Neither, okay? So Andrew, do you agree with him? Do you agree with him? He said neither. Huh? Okay, why did you say neither, Graham?
Because they're not reciprocal.
So yeah, my fractions are flipped, right? This is 2 over 7, this is 7 over 2. So the fractions are flipped, but Graham, they're not reciprocals, they're not opposite. They don't have a different sign. Okay, they don't have a different sign. So yes, the fractions are flipped, but they are not parallel because they don't have a different sign. Those are both positive slopes. Those are not going to intersect at a 90-degree angle. Will they intersect? You betcha. But not at a 90-degree angle. All right, parallel and perpendicular lines. Parallel and perpendicular lines. All right, write equations of parallel and perpendicular lines. All right, so again, parallel lines have the same slope. Perpendicular lines have opposite reciprocals. So number 1 says, write the equation in slope-intercept form of the line that is parallel to the graph in each equation and passes through the given point. Alright, so again, point slope form is y minus y1 is equal to m times x minus x1. So I'm going to give you your slope because I know it has to be parallel, which means it has to have the same slope. So if I give you a line, all you got to do, boom, there's your slope of your new line. There's your m. So I know right now that m is equal to 3, and I've got the point 1,5. So this is going to be x1, this is going to be y1. So let's plug and chug. y1 is 5. That puppy goes right there. M is 3. That kitty goes right there. x1 is 1. That orangutan goes right there. Alright, so let's go. I got y minus y1, which again is the y value of my point, which is 5. So y minus 5 is equal to m, 3, times x minus the x value of my point, which in this case is 1. So now let's go ahead and convert to slope-intercept form. Again, you've got 2 steps to convert to slope-intercept form. Step number 1 is to distribute the slope. So I'm distributing, in this case, a 3 to both terms inside my parentheses. So I've got y minus 5 over here is equal to 3 times x, which is 3x, 3 times a negative 1, which is a negative 3. So first step, distribute the slope. Second step, solve for y. So I need to get the y by itself. I need to isolate for y. Opposite of a negative 5, so the inverse operation of a minus 5 is to add 5 to both sides. That goes away. You get y equals 3x plus 2. There you go. There's a line that is parallel. Again, parallel means they have the same slope. So it has a slope of 3. Guess what? My line better have a slope of 3. And it passes through the point 1,5. Parallel lines. Parallel lines. Alright, so looking at number 2, I need to do what? What's my first step, Ryan, to get my slope? Because again, you need your slope. You've got a point, but you need your slope to be able to plug into point slope formula. So what's your first step, Ryan? What do you need to do with this equation right here? Can you get your slope from that equation right now?
No.
Why not?
Because y is not a
So it's not in slope-intercept form. So guess what you need to do, Ryan?
solve for y.
Yeah, solve for y. So I need to move this 5x.
Minus 5 by both sides.
Fantastic. So let's subtract 5x on both sides. That goes away. You've got 2y equals negative 5x plus 8.
Divide 2 by both sides.
So divide everything by 2. Fantastic. All right, so y equals negative 5 over 2. Let's just leave it as negative 5 over 2. X plus pho. Okay, so now why do we do that, Ryan? But what do I need out of this? What do I need? You've got a point. You need your slope, right? So again, this was not in slope-intercept form, so you got to put it in slope-intercept form to be able to get your m. Because again, I need slope. I already have a point to be able to plug into point-slope form, right? So I've got a point, but I need my slope to be able to plug in and find my line. So you found your slope of negative 5/2. And again, we want lines that are parallel, which parallel lines have the same slope. So Ryan, my m is what? Negative 5 over 2. Alright, so now we're plugging into our point-slope form, which again is y minus y1 is equal to m times x minus x1. Alright, so Andrew, help me out. I've got y minus. Okay, no, that's m, buddy. Alright. So m is going to go in place of m. What's y1? Y1 is the y value of my point. Okay, so I've got y minus negative 4. Okay, hold on. Equals m, and you told me m was what? So let's plug that in now. Times x minus, and what's x1? Positive 4. Fantastic. Alright, so now you already went ahead and told me that this minus negative can become a plus, right? Because two negatives beside each other, change. So I've got y plus 4 is equal to, let's go ahead and distribute here, Andrew. So I've got negative 5/2 times x and a negative 5/2 times a negative 4. So negative 5/2 times x is just negative 5/2 x. And then I've got a negative times a negative, Andrew. What's going to happen? Positive, you said? Fantastic. Okay, so now I've got 5 over 2. And I'm multiplying by 4 over 1. So again, when I multiply fractions, I do top times top, bottom times bottom. So Andrew, 5 times 4 is, and then on the bottom I got 2 times 1. What's 20 divided by 2? Alright, so here we go. You got one more step, Andrew. Is this in slope-intercept form? No, so I need to move this plus 4. How do I move a plus 4? Fantastic. Now the y is by itself, which is exactly what I wanted. So negative 5/2 x. What's 10 minus 4? 6. Perfect. Alright, so those are parallel, right? Again, those are the same slope. So looking at 3 and 4, I need perpendicular. So again, two steps. First step, opposite, which means to change the sign. Second step, reciprocal, which means to flip the fraction. So first and foremost, you got to grab your slope from your first line. We're doing the exact same thing, right? So 1 and 2, I grabbed my slope, which my slope was 3. But I wanted a parallel line, which told me that has to be the exact same slope in my new line. Because parallel lines have to have the same slope. This is not the same, right? These are perpendicular. So let's grab our slope of 1/2 right now. But then let's do these two operations to it to make it my perpendicular slope. So the first operation, I need to change the sign. Right now it's a positive. Change the sign means I need to make it a negative. So my new m is going to be a negative, and then I need to do one more step, right? It's 2 steps. I change the sign, and I flip the fraction. So it was 1 over 2, now it becomes 2 over 1. Negative 2 over 1, I can just reduce to negative 2. All right, so the new slope that I'm going to plug in place of m is a -2. So this is the exact same thing we just did up top. We're going to plug into point slope form. Y minus y1 is equal to m times x minus x1. So I know the m, I just found it. It's a -2. That's going in right there. The y1 is the y value of my point, which in this case is 7. That armadillo goes right there. The -2 is the x1 value, the x value of my point. That koala goes in place of x1. Alright, so let's plug and chug. Okay, so I've got y minus y1, which again is the y value of my point. In this case is a positive 7, so y minus 7 is equal to m, which we found as a -2, parentheses x minus x1, which is a -2. Alright, so let's go ahead and make this look a little neater. Y minus 7 is equal to -2, parentheses x plus 2. Again, I can change in here. And now let's convert to slope-intercept form. So again, 2 steps to be able to convert. First step, distribute the slope. So in this case, the -2 is going to be multiplied by the x and the positive 2. So y minus 7 is equal to -2x minus 2, minus 4, you dum-dum. Alright, then last step, solve for y. So I need to add 7 to both sides. That goes away, you get y equals -2x plus 3. Fantastic. Alright, so looking at number 4, okay, last one, looking at number 4, I need to put it into slope-intercept form to be able to grab my slope. Alright, so Hayes, let's put this one into slope-intercept form. How do you do that? No, that's point slope form. I need to get it in slope-intercept form so I can get the slope. Slope-intercept form is where y is by itself. Is y by itself right now? So let's solve for y. Alright, so what's the first step to solve for y? So let's leave that here for right now, and let's get rid of everything else that's with it. Well, what's with it? Yeah, so I need to get rid of that x. So how do I do that? You've got an x right now. How do you get rid of it? If you got $1, how do you get rid of it? Yeah, you spend it, right? Okay, so you would add it, multiply it, divide it, subtract it. So subtract what? Hayes, we're leaving that there. You just told me we're leaving that there. We're subtracting what? Look up there, dude. What's there?
Are you subtracting x from those 2 points? Or just subtracting?
Hayes, I'm trying to get it in this form, but y equals mx plus b. I don't care about that right now. That has nothing to do with this.
So you just subtract x.
On both sides. Okay, so we're subtracting x right here. We're subtracting x right here. Don't look at that point. We're not using that yet. Alright, so that goes away. You've got positive 4y equals 12 minus x. Alright, so now, is the y by itself, Hayes? Okay, so this is 4 times y. So let's get the y by itself. How do I get the y by itself? Fantastic. Okay, so I'm dividing by 4. So I've got y equals. Alright, now I'm going to rewrite this order, right? Because I want the x to come before the y-intercept. So this is a negative x over 4. So I could say a negative 1/4 x. Because there's a 1 in front of the x. So I've got a negative 1/4 x, and I've got a positive 12 divided by a 4, and I get plus 3. Alright, so now, here is my slope-intercept form. Okay, now why did I do that, right? I'm trying to get the slope from there. So right now the slope is a negative 1/4. So right now the slope is a negative 1/4. Now, let's go back to my question. My question says, write the equation in slope-intercept form of a line that is perpendicular. So I've got to make two changes to this negative 1/4. My first change is I'm going to give it the opposite sign. Second change is I'm going to flip the fraction. Riley, help me out. I've got a slope of negative 1/4. What's my new slope? Positive 4 over 1. Okay, I don't need to write over 1. I can just write positive 4. So again, the slope was a negative 1/4. We do two operations to it. First operation, change that sign. Second operation, flip that puppy. Alright, so I've got a slope of 4 in my new equation. Now I can look at my point, which is a negative 2, comma negative 6. Again, we're plugging into point slope form. So y minus y1 is equal to m, x minus x1. Graham, help me out. Let's plug and chug.
Y minus 6.
So y minus almost.
Oh, is it plus 6 or?
Yeah, so y minus a negative 6, right? Okay, so it's already minus in my equation, in my form, and then I'm plugging in a negative, right? So y minus negative 6 equals m
4
times,
x minus 2, which is plus, it's same thing, plus 2.
yeah, so x minus a negative 2, right? Not just x minus 2, x minus a negative 2. Alright, so yeah, you've already said this is y plus 6, change, equals 4. This is x plus 2. Alright, so Graham, let's go ahead and distribute the slope, right? Because the first step to convert to slope-intercept form is to distribute your slope.
So 4x plus 8.
Fantastic. Last step, solve for y, so I need to get rid of this plus 6, subtract 6 on both sides, and I get y equals 4x plus 2. Easy breezy. Lemon squeezy. Where is my mouse at?